Doom, doom, doom. As I suspected. Let's actually get one more reading on that. Hello, people. Actually, we were streaming during that, so let's not. Let's try it again. Or we had video coming in off the web browser. Okay. This is about the same as what we just had. All right, so I'm going to do the same thing where I go here and I say yeah, it's so this is 212 exclusive, 821 inclusive. This one was I could sort it. 212, 821. This one is 200, 759. So, you know, the thing that I'm actually surprised by is this frickin' one. 267 exclusive in that thing. Holy crap. That's a lot. That kind of shocks me, but it's good. It means there's lots of headroom. Preparing for colonoscopy. Well, colonoscopy. Yeah, well, I don't know what to say about that. I don't know anything about that topic. Good luck. Good luck. So what we're doing is, as I mentioned on a previous stream, maybe it was this morning, I did a pretty heavy overhaul of the way type inference happens. Like the main actual loop of type inference was changed over Christmas and New Year's. And the new version is ostensibly much better. However, you know, it's the first version of it and it might have too many if statements and be slower. And it did seem to slow down the compiler by like, well, this is telemetry build, but like by more than 100 milliseconds, which is really a lot, given that this compiler completes in like 800 milliseconds. So I basically need to go in and see what I can do to make it faster. I don't think it's inherently slower than what we did before. In fact, I think it's in principle inherently faster. However, right this second, it is definitely not faster. And so I just need to look at all these frickin' if statements and see what I can do. Wait, does telemetry define underscore debug? I don't actually know. It might. If it does. No, it doesn't appear to. Yeah, okay. So these things that are slowing it down in debug build are not actually slowing it down here. So like there's all these things that happen for each expression, and I just need to cut down the number of if statements, I think would be a good start. A stream of handmade where Casey's drinking the poison. I don't. Is that also a colonoscopy thing? What is going on? How come I don't know anything about this topic and everybody else does? Okay. So basically we look on this stack. And this part used to be here before. Maybe we could do something about this. Here we maybe flatten the thing and continue. So this is going to run a lot for leaf nodes and not do anything. But I'm not sure if it's worth putting more if statements in here to try and avoid that. But this is a possibility. Like literals and stuff are gonna go through here, and actually, let's go take a look for a second. Oh, right. If it's an array or struct literal, we do things anyway. Except yeah, we might export that to something else. But anyway, for most literal, like number literals and strings and stuff, we don't do anything there. And then we do this crap. Where we infer the types. And we have an if about if it's a block. And then we have a goto. And then we have another if it's not a block frickin' down here. This one is weird. So okay, I feel like this case probably doesn't need to fall through down to here. Maybe it does. Okay. So I think I can start factoring some things out. So like this block info variable we could factor out, but it'll probably end up on the stack because we call things, and it's probably about Let me see this. Like, this is a weird thing because I don't see any obvious place to start and get a big win. But we definitely need to do less work here. This is very slow. But hopefully we don't get there that often. I should profile this. Oh, we do. Let's go see. Need size to build is 19 milliseconds. That's not great. It's also not the worst thing I ever heard. Casey was just being a hipster. All right. This inferred expressions. What is that for? I think we use that to estimate something. We use that to estimate the number of bytecode instructions. Honestly, probably not that useful. We could ditch this. That said, maybe we can This is one of these things where all the individual things are small, but they add up. So we can get rid of this. We might pay a perf price later by getting rid of this here. This isn't very expensive. There's no like data dependency on it. But still, if you don't ever start getting rid of things, you don't fucking get rid of things. You know what I'm saying? This like block popping scenario could be done differently. We could just always push the block with the expression. That might just be more expensive. But it would mean we don't do a branch there. This stack pop serial thing I'd like to get rid of, but we're using that. Why do we have an interp reported error here? Like really the place where that should be like here. Like I kind of want to move this to here. I'm not sure if that really helps much. Oh, you know, we have this. Okay, I remember. I did this because we were getting a null type here. Why don't I move this out and then we'll put it here. That doesn't help a lot, but it gets it. This is a weird place to put that. Because nothing in here should generate, the error would be generated in infer. So we check for it after we may have generated it. Okay. So put this up here. Okay. I would like to make this much faster somehow. I don't know why we're doing this twice in a row. It's like, okay. Okay, hold on. One thing, we're going to be very conservative. We're going to go back to debug build for a bit and see if assertions trip, and we're just going to remove some if statements and play around. Looks so far like it's working fine. How is everybody? I hope most people are not getting a colonoscopy. That's what I hope. I mean, if you want to do that, it's fine. But like, if everybody's doing the same thing, it's no fun. You have yet to deliver value. Well, you got to get started delivering value some frickin' time, right? See, this stuff here, this whole if statement about if it's a type definition, if it's a type instantiation, this already happens because we go down into this giant switch statement, right, where we infer these. So what we could do is we can do it at the time when we set these things, and then we don't need to check for it here. And that can simplify some of this. We could even do it when we call set inferred type, and then we don't have to do any of this stuff. The problem is set inferred type gets called from more places than this file. But we could do that, and then that would get rid of all of this code. Which honestly is probably a good idea. Because like this is not a very predictable branch necessarily. I mean, it's probably null except when it's not. This is not a very predictable branch. I mean, it's probably not these things, except there are a lot of these things, right? And so we miss every time. So like, yeah, we need to move this shit. Okay, hold on. I changed the block checking, so let's make sure we run again. So first step is just going to be to move each of these guys out. We're going to do type definition, right? And then we're going to do type instantiation, and so on. Let's go look at need size to build again. Yeah, I'm a little worried about this, but like, All right. Okay. This one's weird. This one's weird. Anyway, okay. Why are there two arguments? The requester. Do we even use that? Not really. All right. Okay. So we should be able to not do this and still run just fine. Whoops. We're programming in C++, so we can't simply do what we were trying to do. Oh my God. Giant fucking failure. And the reason is, I think, yeah. So the problem is this, for example. So like if it's already inferred, we won't need size to build it, even though we don't know about it. Sag. I mean, I could try reformatting this slightly, but I don't think it'll be a big win. I think we might get a tiny. So we used to, in the old format, we had like all expressions linearized, and we would just spin over all of them and just call this, and that was probably a little bit expensive anyway. I did see licorice pizza. I did not eat licorice pizza, but I saw licorice pizza. Movie of the year? It was all right. I mean, I have this thing with PTA movies where the stories to me often seem aimless and I don't know. Like this movie was a lot like Phantom Thread in a certain way. Where it's about, hey, there's this relationship going back and forth, and then there's problems, and then at the end, and we just decided it was the end and it's solved. And why? There's no reason. It's just time for the end of the movie. It's like, eh. Eh. It's all about the characters and setting. Yeah, I mean, the characters are really good. I'm ashamed to admit, I like the restaurant owner dude. He's probably my favorite character. Comparison, is that what I said? Dude, it's on the video. Anyway, let me work on this. See, we're kind of calling get inferred type multiple times. Because we're calling it up here, and we're calling it down here. We're setting it. There's just like, there's a lot of things that are happening that are quasi-redundant, but not obviously completely redundant. So it's also coming toward my bedtime because I'm still on East Coast time. But I would like to get at least some win. And we've got a tiny win so far from like deleting a couple lines, but we want a bigger win. I wish I knew. Let me look up this need type info to build. We had that note in need size to build, right? We're like, oh, type info required to build. Why? Because if we return a type definition, but that's only for type definition. Let me see. Like this is just like a lot of a lot of ifs. All right. We could maybe have some flag set that is common for all of these and just use it. All right. Type info required to build. In order to build any procedure that uses that type definition, when we emit bytecode for type definition, we do get type table index. Right. Okay. So anytime you use a type as an expression, but again, that's for type definition. So can get rid of the yield and the condition and need size to build. I mean, that could be a win to get, but it's not related to the added slowdown. It's just, it would be a compensating win. I don't think there's no yield here anymore anyway. So that part is fake news. Okay. Why do I comment so much code instead of removing it? Like what? I don't see commented code. Okay. So this pusher index down here, ignoring thinking about this for a second, this pusher index could just be in a local variable. And that might be slightly faster. The thing is, if somebody pushes a block, which is going to happen, then that needs to update. And so we don't really get a win. I think it might be faster to have the block and the expression be pushed at the same time. Which seems a little bit slower, but it would get rid of this. I mean, that's just a debug check, but. Have I looked at the cause profiler? No, I haven't. So I'm pretty sure I'm using this. Yeah, this is for ordering things right now. Bleh. Bleh. Blah, 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 blah. How long have I lived in SF? A long time. I don't even want to think about it. A really long time. What will be my final words? I have no words for this place at this point. I have no words. This is like, there's just so much code here that I would like to get rid of. Am I going to move to Texas? No, I already moved to Florida. I just haven't abandoned my San Francisco place yet. I already have an apartment in Florida. Future perf streams, maybe. The problem is I have so much to work on right now that is not this. I just wanted to get a little bit of perf in while it's the weekend. And it's not that easy right now. Not that easy. Whoops. Just jammed my finger into the microphone. Like there's all these little things that we are using. The reason I'm not crazy about packing the block in with the expression on a single stack is like, what if that's not faster? You know, it's like not, because we're not exactly getting rid, like anytime you just can delete some code, that's probably faster. If you're removing some code and replacing it with some slightly other code that's maybe less, but also has different performance ramifications, it's hard to know if that was a good choice or not. I am doing a lot of this not equal to asked block bullshit. So what is going on there? Why don't I just, while I'm doing go to the amazing go to scenario, why don't I just add some more go-tos? Because fuck it. Then I can we'll put a no check in here that we're going to assert that. So here we go. We're going to go blocks don't get queued. It was a block. Okay, this is not really recommended programming practice, but it's gonna get rid of an if statement here. So let's just make sure we're working. And the reason that gets rid of an if statement is because down here, let's delete that old comment. Let's delete this. Here we can just assert. Oh shit, we can't. Because we substitute for block. It didn't even help us. Right, I knew this before and then I forgot. There is a case when we set a block as the substitution, but maybe in this case that's a... Because I think we demand... so much set substitution. Picking an apartment, just get what you like. Like, everybody's different. An apartment I like isn't necessarily going to be one that you like. Okay. I'm looking for anyone who calls this with false. Somebody must. I don't... really see it though. Like what's going on here? Let's just assert on this. And if we literally don't ever call it, we could remove it. But I feel like that assertion is going to fire. Yes, it is. Let's see. Set substitution 1698. Ah, right here where it is a block. Let's see if it fires elsewhere. I seem to remember, so I added that block as a substitution when I deleted, there was an expression type called sequence. So that might literally be the only one, in which case we could get rid of this. All right. And then this. Yeah, mine is more expensive than $2,000, but it's because I'm used to San Francisco prices, and I'm in a building that has like a steam room and a sauna and a nice pool and all these things. It's still overpriced, but it's fine. Okay, so I took those things out. We're going to recompile. Do I haggle on the price? Not usually. Fancy. I just want to make sure that, like, if I'm, like, it's, you know, I'm moving somewhere where I don't know anybody and all these things, right? So I'm just trying to make the move be as nice as I can within reason. So the reason I decided to rent and not buy, because I wanted to take action quickly and not, like, sit around in San Francisco forever. And that lets me do that. And I can decide if I really like the place. Like if I like it, I could buy something next year. Sauna streams, probably not. Dude, I'm too fat right now for sauna streams. We can't do that. Okay, so this is working, which means this part now can change. So we'll put this in some curly braces. So okay. So we've rearranged this a little bit. Is that better? It may be slightly better. It's a little bit more better for other purposes because we could call our optimized version of need size to build, but that's not going to save more than a couple milliseconds, which we may care about eventually. But right now, Right now we care about like 100 milliseconds. So like 3 milliseconds, I don't, it's like, eh. Do I enjoy the beach? Sometimes. Not all the time. But sometimes. Went to the beach today. California beach. Okay, wait. I totally didn't do the right thing here. Like, how... Yeah, okay. I was going to say, how did that work? And it didn't work for everything. Okay. Whoops. Let's try again. Okay. Actually, hold on. Whoops. Can't create what is happening? Okay, so this part only needs to be in here as well. What is this? Why is this up here? I don't like that. Okay. We're just cranking along. We're just cranking along. I'm definitely starting to feel the tired. Here we go, though. All right. I kind of want to run another telemetry and verify for myself that this has had absolutely no effect on runtime speed, despite that I wish that it did. It might have a small effect. But like, there's also just no, these aren't very precise measurements we're taking and so forth. So, all right. So we were looking at 200 to 212 before, right? And we didn't really touch this one. All right, so it's probably a faster way to get to this, but same. I told you, exactly the fucking same. I mean, it's not the same as this one, but it's the same as this one, and there's noise. So, like, I kind of want to keep hammering on this a little bit later, but, like, it's not that easy to know what to do. I had the feeling, like, dude, this has had no fucking effect on runtime. So this is just something I need to think about. Like, what do we do here to lighten this load? Let's, however, look at this other thing, because this function is actually more expensive, which I'm a little bit surprised at. Like, what the hell is it doing? It, in principle, should not be more expensive than this. Although, maybe pipe pumping is included. No, because pipe pumping is down here. Dude, I don't know. Okay, let's just take a look at this. Maybe I made that more expensive and didn't think about it. So that's this function right here. We call pump pipe, which pump pipe has its own zones. And we're not setting the name correctly anymore. So like we can't, I think this is all the pipes together because they're all called null right now. Anyway. There's so many things we can optimize. It's crazy. All right, so what is going on? We do this. This hopefully isn't expensive. Start one phase. That does basically nothing. Very little. I mean, we call new in here, which kind of sucks, but we don't, in theory, do it very often. But like, there's not a real reason to do that. Let's just do this. And we're not going to bother releasing it, but sorry. Yeah. We're not going to bother releasing it, but there's so many things we don't bother releasing right now. It's not going to make a difference. We'll reclaim it later. And we'll just make sure that runs. It really should. Whoops. Why did it say, oh. All right, anyway. So we get a queued. We put queues in the current job. This is like a flat array. We remove it from the pipe. Do job infer of current job. I sure assume. Oh, this doesn't. Okay. Let's TM function this, because this is probably what's slow. Oh, god, crap, guys. I've been running the debug build. Oh, fuck. Visual Studio is bad. So, yeah, let's run this again. We weren't, see, I knew it. I was like, we weren't really testing that, and we weren't. And now, I have no idea what broke. What did I change, guys? It was the get memory new? I don't think so. Did it say that? I don't know. What? Why was that broken? New, get memory size, size of type. What is your major malfunction? How is that wrong? Like literally everybody crashes. New, get memory sized. So it's a placement new on the pool. I don't get it. Did I vacation at all in Florida? No, I've never been to Florida before this year. Never been to Florida. I'm not in Florida right this second, but I was a couple days ago. Okay. There's something wrong with the pool allocator. I don't know. I'm just going to run this. And we're going to see where it frickin' crashes and why. I doubt something's wrong with the pool. I think I'm just doing something really dumb and I'm just tired. I don't feel that tired. I feel a little bit tired, like, oh, I kind of want to start going to bed, but I don't feel like super impaired tired, although maybe an aspect of being tired is you can't judge how tired you are. Also, jet lag tired is a little bit weird, right? It's like a little bit different from just, what are we even doing here? Why is this taking so long? What is happening? Let's just nuke all these. Oh, there we go. I literally selected these and then it put my focus in the other window because Visual Studio is an asshole. Why? Okay, here we go. Oh, because we're calling frickin' delete on it still. I guess there was more than one. Oh. Yeah, you know what? Let's not even bother with this yet. So the problem is this thing that deletes the job is not the only site that could do it. And I think the other site is like a general, I don't know. We'll think about it later. Okay. The point being, I don't necessarily think this is that slow. If it is, it's a pretty easy thing. I mean, okay, calling the heap allocator is pretty slow. We just don't necessarily do it that often. Yeah, anyway. What I should probably do is switch all of these to get it this way. It's just, as soon as I think about that, I'm like, maybe I care a little bit more about the fact that it's leaking memory and I want to like do a different thing that's slightly higher effort. We'll look at that in a bit. Why am I doing this? Okay. So what I wanted to do was look at that breakdown, because I put a TM function in whatever that other function was that we call, right? Let's refresh our memory. In do job infer, and that could actually be a lot of the time. So we just want to know, is that the case, right? All right, profile zone. So this is the function we were looking at. It's most of the time. Do job infer is like 50 milliseconds. It's not nothing. But this is most of the time. I mean, let's just put a little bit of stuff around the new, because this is a relatively straightforward, mindless thing. So we could do that. And we could do this. And that doesn't take into account the other delete. But wherever that other delete is, oh, there's one right here. That was probably it, actually. So we could probably switch this over. Just for some reason, I thought it was elsewhere. Whoops, I just didn't look off the bottom of the screen. That's why you shouldn't play Counter-Strike in 4x3, guys. Pros don't fake. All right. Boom. No, that's the wrong one. Boom. Profile. Wait, that was a little bit of a slower run. 286. I mean, it's going down a little bit. Do job infer 4874. New delete. I don't even see. There it is. 1.78 milliseconds. Yeah. So like I'm saying, it's not that fast of an operation, but it's not like happening that often. So it's good to be able to attach a number to it. That number is not that high. Actually, does it make 3 separate zones, or does it like put them in the same zone when I do that? I think it puts them in the same zone. Anyway, how many calls? 10,000. Yeah, it's like, we want to get rid of that eventually, but it doesn't matter that much. So what I'm a little bit surprised by is the number of calls to this. It's a fucking million. Now, the reason I'm surprised by this, so this thing loops over and calls this thing, right? If this thing is called, and it should call this thing many times for each of its thing, hopefully. Toward the end of compilation, or as you approach bottlenecks, it's maybe not so good. So if this is a million times, this means that sometimes we're cranking through, a lot of the time, most of the time, we are probably cranking through here and not doing any work. And that seems bad. And I don't know if That would be a very interesting thing to know. So let's find out if that's true. And then maybe that's a place to end the stream, is just for me to think about what to do about this. But that is actually kind of shocking. Because, so the theory is like, okay, if we call this and there's nothing to infer right now, it's not that bad because like other stuff is happening. Like other pipes will run other pipes and stuff will be going through them and etc. Right? Um, and so that even if there wasn't something to infer this time, something that's blocking us will fall through one of the later pipes, right? This is complicated by the fact that we have a meta program running that might submit new stuff or whatever, but we're supposed to be sleeping on that. We're not supposed to be like busy waiting, fucking cranking through this function. Oh shit. Guys, this is the wrong function. That's why I'm tired. I'm impaired because I'm tired. This is interp infer types. This is typer inferred. Guys. The function that we're looking at is 3 milliseconds. I'm looking at it being like, I can't tell what's slow because it's not that slow. Oops. All right. Well, okay. That's fine. This one happening a million times makes complete sense. Complete sense. Because it runs for every node in your syntax tree. It's easily a million nodes, no problem. Okay, we figured it out. Think the cause profiler might be good for finding optimization, good for finding... Yeah, I know what it's for. This code is not multi-threaded and highly dependent, however. So we don't really need that here yet. All our problems here are single thread problems. Okay, one of the perils of having different functions with the same name or similar names is you can get confused like here. Okay, this is just the thing that infers every expression, and I'm not remotely surprised at this. Now, that said, the active domain services is current. That's great. Oh my God, look at all these calls. Fuck. I was hoping we didn't have a lot of calls to this. But we totally do. Some of this is like old and should be done in a different way now. We really shouldn't necessarily do that directly. Yeah, oh God, we do a lot of this. Okay, I'm not going to try to change all this right now. It's actually not that much because all these are commented out and whatever. And this is error stuff anyway. It doesn't matter. So like this, we could move this and maybe move this. This really shouldn't be a flag, right? I mean, this is an easily predictable branch, but it's in there polluting everybody. And then we do this big switch statement, and hopefully the compiler is doing something to optimize this switch statement, but like, maybe it's not. Still going. Still going. down there. There we go. Okay, so we actually don't need this. I don't know if that's ever going to confuse anyone. Oh, actually we kind of do. Let's do this. Just because I don't want anything confusing this scenario. What a nice function. Okay. Perl for a half a sec. Well, it could be Perl. Could be Perl, everybody. Like, okay, I kind of would like to get rid of this. But there's a lot of people calling this that may have to ensure this themselves or whatever. We could do that. This I would like to move out. And we can make a unary operator called the spread operator. And I should have done it that way from the beginning. That's not a critical change that's going to change a lot of things, but it would move this stupid ass if statement out so it doesn't get checked for every single expression, which is not going to impact our numbers materially, I don't think, but would be a slightly nice thing to do. You know? And then the thing is, if we get into optimizing this function, it's like, is a lot of analysis required, I think. So I don't know, guys. Why are these flashing? Oh, because it's what I have selected down here. It's a very annoying flash, guys. So actually, I guess I can look at this for a bit. So this is the function that's kind of slow, and you can see that there are chunks here where it's like doing stuff. Sometimes quite large. So it's, see, it's 816 inclusive, 200 exclusive. So 3/4 of the time is actually in this stuff, in the callee, right? But these chunks, they do add up. Like, what are we doing that takes that long? I kind of don't know. Like, this is like 700 nanoseconds, because that's how big this is. That's like almost a millisecond. Now I'm confused, because my model was, we're just looping through this thing and all these if statements that we're doing. Are kind of trivial, but they're happening for every expression, so they're adding up. But like, that's not, oh wait, a nanosecond, never mind, not a millisecond. Okay, 700 nanoseconds is almost a microsecond. Yeah, okay, sorry, I was looking at a wrong time scale. Maybe I believe that. Maybe I believe that. Sort of the bigger meta problem here is we're calling down into this function a lot to do small amounts of work each time. Sometimes it's a lot of work, but like it's really mostly not. Like here it was huge. Maybe actually we want to figure out why that was so damn huge. But usually it's not. And like, like calling into a function a bazillion times, actually 1.1 million if we decided, to do a small amount of work every time is not that good of a policy, right? You would rather do fewer calls with more work per call. I don't really know how to do that offhand right now, but it would be an interesting thing to think about is how to refactor this so that that becomes possible. Are we selling our company office? We never owned a building. We always rented a building. Bucket it somehow. Well, that's a thing to think about would be how to do that for this particular problem. It's funny because these holes don't look that big, but they're like a quarter of the time. Ay, ay, ay. Here's a giant ass chunk. And none of it is in need size to build, which is weird. I thought we should see that zone here. It's got a thing. Oh no, we do. Okay, we do see it. It's just little usually. Maybe we should color code that. Yeah, it's every other call, right? Because we do, or not, approximately every other call. So interestingly, so most of these calls to need size to build are a waste of time to begin with. Like, because most of them are redundant information we don't care about, etc. Now, if you imagine taking that function and then the holes on each side, and just imagine that this function is now a hole as well, it becomes a much bigger hole. I need to figure out, I would like to figure out a way to do need size to build like better. Are we inferring types multiple times for the same expression? No. We do check that, but checking that is an if statement that runs for every expression, which we would rather not run. There's like a bunch of if statements for every expression right now. We don't want that many. So what the need size to build is about is just like saying, hey, the bytecode builder doesn't yield, so when we go generate code, before we go generate code, because we can't stop in the middle, we do this pre-check where like we record all the types that that's going to deal with, and we make sure that they're all past a certain part of the pipeline. Now that is overly conservative. It's bad for parallelism because you don't start any of the work until you can do all of the work and stuff. But also, it just takes time to do this check. And one thing I could do is try to make it faster, right? Try to streamline it. The other thing I could do is not do it this way. The other thing I could do is say, screw you, bytecode builder is going to yield now, which is scary because I've spent a lot of time and effort on the nonlinear compilation, and it's a giant ass pain in my ass, right? But I did sort of figure some stuff out, and maybe it's easy to make bytecode builder yield. Like that might literally just be a thing, or actually, like I was saying in the comment, the reason it yields now on this type stuff is because of the type table indexing. And if I change the type table indexing, that goes away. For that particular case, is that the only thing that we need? That's like a whole side investigation that I don't want to do right now because I'm tired. But like, okay, I think that is my choice of how to approach this problem. My choice is I want to get rid of the need size to build thing, not by having bytecode builder yield, but by changing the type table indexing and or investigating what else. That would be step one, is investigating what else we possibly need the yielding for. Because that could be a deal. It could be that like, oh, it's something where it's like, oh shit, that's not easy. RIP, right? I guess someone's going to have to yield somewhere. So if we change the type table indexing, that means we could wait till later when we're generating. I mean, we patch it in at the very end. That would be cool. I kind of like it. All right, everybody. I'm thinking about signing off and going to bed because it's late, but we need some messages from our sponsors.
The world is full of difficult choices. From small things like what vegetable to have with dinner or what book to read, to big things like who will be that special someone or which candidate you should elect. These choices can be daunting, but we have the solution. The next time you have to choose, relax. The right music? It's these guys. The book to read was Proust. That special someone was your old Plan B, Dave. The right candidate was this lady, and the vegetable was lettuce. Every day we help millions of people choose a better life by choosing it for them. Face goo my crapama. Think of how great your choices will be when they're made by us.
Okay, now that we paid the bills. Yeah, okay, so I'm just going to make sure that this runs. I think we got probably a very small speed increase that's hardly measurable today. That's fine because it moved the thought forward. It cleaned up the body of this thing a little bit. Yeah, there's definitely, I want to get some creative ideas about how to tersify this. This peak pointer thing, this could be slower due to potential aliasing. Like I was saying before, we could copy this value. But I don't know if it's going to be actually faster anyway, because like this shouldn't really be that slow of an operation. Yeah, okay, let's see. Let's see this. Could I set a Boolean in a lookup table per expression? Boolean of what? All right, everybody. Thanks. We'll stream again sometime soon. If the type has already been inferred, I mean, how do you have a lookup table that's... You would have to have all your expressions serialized globally by integer to do that. And that may cause you other problems, right? All right, thanks everybody. See you later.